This is another question that we can analyze using the lens maker's equation. Previously, this sandwich bag was filled with water, and it can act as a crude converging lens in air. If we think about the shape that would make, it would look something like this, and initially you have water inside and air outside. So you would have an index of refraction of 1.33 inside and an index of refraction of 1 outside. So we're told that initially that this acts as a converging lens, meaning that the focal length has to be positive. Now, if we take a look at the index of refraction of the lens divided by the surroundings, that would be 1.33 if this is filled with water, 1.33 divided by 1 minus 1, so this is positive, this term is positive. And that tells us that this term, which is influenced by the shape of the lens, this also has to be positive. Both of these are positive in order for the focal length to be positive. Now imagine that we pour out the water and the sandwich bag is filled with air. So now if the sandwich bag is filled with air, its shape doesn't change, so this term is still positive. But if it's filled with air and surrounded by water, now this is 1.33 and this is 1, so you're going to get a number here that's less than 1, so when you subtract 1 from it, you'll get a negative number for this term. So negative times positive, that's negative, and your focal length would be negative, so this is now a diverging lens. We can kind of also see this if we think about a light ray going through our lens. So if the lens is filled with air surrounded by water and we send a light ray in, the light ray strikes the first surface, and if we look at the line parallel or perpendicular to the surface, we know that we're going from a high to a low index of refraction material, so the light ray has to be bent away from the normal. So this angle here is going to be smaller than the refracted ray, so it will look something like this. Then we strike this second surface and the light has to be bent towards the normal, which means if this is some angle, then we have a smaller angle on the other side. So it ends up going something like this. So we have a light ray that moves like this through our lens, and we can see that it's being bent away from the principal axis. So that also indicates that we have a diverging lens.